Today's webinar is about planning, the optimization of the plan. So as you have read before, this webinar will be in English, as we have participants from all 40 countries, and as we have a Siemens representative, which will show the tool called Preactor. Today's webinar will take 1 hour and 15 minutes, and we hope to fit in the schedule. Why we do this webinar? First of all, we get a clear signal from the market that planning optimization tool is required and might give a help in cost optimization. We have few implementation in the market, whereas customers are sharing their experience. And I would say we have a grounded understanding that such tool brings significant benefit to companies' performance, and those benefits will be highlighted in this webinar. Organizational part of this webinar. First, questions. Questions during webinar, you can type directly in the window, so I'm showing right here. I will try to post them on the appropriate time, or I will give verbally to presenter in order to question to be answered during the webinar. Some of them, I believe, we will answer after the webinar. Material. Webinar material and recording of this webinar will be distributed after the webinar will be ended. So, having said that, I'm glad to give the floor to Michal. So, Michal, the floor is yours, and please present the best of the Preactor.
Okay, thank you very much, Davidas. Good morning, everyone. My name is Michał Pęczyński. I'm responsible for the implementation part at our company. My background is, as I said, mainly the implementation of the systems. I have been engaged with planning and scheduling problems and solving them using Preactor since 2002. I will take you through today, and I will discuss a little bit more once I share my presentation with you. So hold on a second, I will just share my desktop.
Not here.
No.
Michal, can you share it again?
Yes, hold on a second, it's coming, connecting. Okay, we're going to give it one more try, sorry about this. As usually, it was working on the test perfectly fine.
It's coming, I see. If everybody has seen on the screen.
I think it should be fine now. Okay, first of all, you can also if you want to put it on the full screen on the right side of the window, the full presentation as we go along. So let me just take you through the agenda. Because I'm coming from the implementation side of the things, the first thing we try to do with our customers is to understand the problem they have, And here I wanted to specify some key challenges that are to do with the planning and scheduling that has been identified during the implementations for food manufacturers. So I will talk a little bit more about the planning and scheduling, those key challenges, and then we're going to talk how Preactor, SIMATIC IT Preactor solutions, so that would be advanced planning and scheduling system, can meet those challenges, and I will do a little bit more of the introduction in regards to the company itself and the background and some of the key implementation. Once we are done with this part, we will go straight into showing you the system. So I will do a live demonstration of Preactor AP, which stands for Advanced Planning and also Advanced Scheduling. I will use an example from food industry to show you those different levels of planning and how we can do some scheduling scenarios inside Preactor. Then we're going to move on to discuss some of the potential benefits that has been recorded by our customers, either through our own experience in terms of implementing Preactor, but also through the side of case studies that are available and some results that have been achieved by different companies around the world. And then finally, a little bit time for questions and answers. So the first part that we try to talk to the customers, and especially in the industry like yours, is to identify, do we have a planning or do we have a scheduling problem? Or sometimes we might have a planning and scheduling problem. The difference between the planning and scheduling is really in the detail that you want to see your production plan. So for example, in the planning area, what you would like to establish is really based on your forecast, sometimes a forecast that might go several weeks, several months, or even years ahead, based on sales orders that are confirmed, for example, for the next couple of months. You really want to decide what you want to produce. What is your master production plan, master production schedule, how much of quantities of different products you want to make. Once you know what to make, then you need to decide when to make this based on the capacity available. And in the planning, we're really looking not at specific production lines or not specific packing lines, but we can look into the aggregated view of your available capacity. Sometimes it might also means that if you have a multi-site, so you have different factories, you might want to have a look at the capacity in those different factories and make a decision where you want to make it. Once you establish what to make, what is your production plan, you want to also calculate what materials are required. So that would involve an MRP calculation in order to calculate the materials that are needed and when they are needed. And also in the planning, you look, as I said before, on the aggregated view across of your resources. Now, if you go down into more details, then you enter the area of production scheduling. And scheduling, otherwise known also as sequencing, is about defining which orders will be made on which lines at what time. You are interested in taking your production plan and seeing if on that level of the detail, when you can see your hours or minutes in the next shift or the next couple of shifts, you want to see if you will be able to make that plan according to all of the details. And those details can also take into account, for example, your constraints of production process. This might involve additional operators that you require for manufacturing. It will look also in the availability of additional tooling that is needed when you want to schedule. In the scheduling, you will also apply execution. So once you start to report production, then you want to see how the plan is being made. And in the scheduling area, this is what you can see. And you can see the actual execution against the plan and how you have to adjust the plan and your production plan for those detailed resources because of the things that happen on the on the shop floor. So that might involve the breakdown or the planned maintenance that has to be taken into account. If we go into more details in terms of the challenges that we try to help with our solutions. So if we're looking at the production planning area, it's really about dealing with the companies that work in the forecast driven environment. So when you want to take into account your weekly or monthly forecast and you want to generate the master production schedule, so your production plan saying how much you need to make over time, this is really the area of planning that you want to deal with. The other things that are quite specific for food manufacturing would be to deal with the product's shelf life. So depending on the shelf life, you really need to know where you want to start your production. Can it be 1 week? Can it be 2 weeks ahead? Or if you have a very short life, it's really something that you have to do all really up to the minute. So on that specific day of the week, for example. When you have a spike, let's say spike in the demand coming from your forecast and the sales orders. So, for example, you are working with a supermarket that requires a promotion. What happens is that you have to see that promotion across your demand plan, and then you will have to see how it will influence the capacity of your resources, and also how it will influence other work orders in your plan. I've mentioned before that for those big manufacturers that are planning really on the factory level, so they don't really go into in the production planning, they don't go into the detailed level of specific machines, but you might have a situation when you have two different factories that can produce the same product. So you really want to make that decision on the master plan, which factory will make it based on their capacity or maybe some additional constraints. Another part is taking into account the materials availability, especially those that are, again, have a very short shelf life. So you really need to sequence the materials planning against your production plan, and this is a part of the production planning, or to be more specific about the MRP planning, that also needs to be taken into account. Now, when you move into the production scheduling, you will see a little bit more in terms of the level of the detailed, and also those problems can be quite specific. How do you sequence the operations? So one of the things is that you will have the multiple levels of production process that you can look into and that you need to plan for. That would include, for example, looking for your mixing resources, so some ovens or tanks, and also your packing resources. That mix of process and discrete manufacturing can be a challenge in production scheduling, so you want to see that connection on your planning board as well. One of the things that the companies in that sector also requires is to look very closely on the changeover times. So for example, if you change from one flavor to another flavor, you might need 30 minutes of time. So let's say you change from a flavor vanilla to chocolate, but when you change from chocolate to vanilla, you have a different setup time that is required. And that might involve, for example, additional cleaning time that has to be planned as well by the planning department. So you need to take into account the cleaning times, the changeover times. They can be quite complex. And also on top of that, any kind of a maintenance schedule. So when you want to switch off some of production lines for the additional cleaning or for additional check, this can also impact the short-term production plan and generating that plan by your planning department. We've mentioned sequencing, so defining what is the best sequence of operations across your resources. Sometimes you might run into a situation, and we have a scheduling scenario that I will show you today on the live system, is that you might have some key ingredients that will actually constrain your schedule. So for example, you cannot have some ingredients done at the same time on the parallel lines because you don't want to mix them together, or you are not really allowed that to mix them together. So you really want to prepare your production plan taking this into account. The next thing that is really a combination of planning and scheduling, but for most of the companies, it's also a scheduling problem. You want to monitor the availability of your operators, and that would include also your temporary labor. So whenever you want to run a schedule and you want to see how many operators you would require, or maybe you are constrained by the number of operators. So you have 7 packing lines, but in reality you can only run 5 of those 7 packing lines because that's enough, or that's the amount of the operators that you have. So from one side you need to have the availability of the functionality that will give you possibility to constrain your schedule, but on the other hand you might sometimes want to run in a longer term a simulation saying how many operators I would need if they were not my constraint. So we had an example of a company that was scheduling in a longer term, and they were calculating how many operators they would need, and they would go to their temporary labor agency to ask for more operators at that specific time. And they all did that calculations and what-if scenarios inside the system. Now, in production scheduling, you might also find the problems that are quite common for many different industries. We also find that way that some of those challenges will interact across different manufacturing scenarios. One of the things that is quite common for people to use in their daily planning, in their production scheduling, is to rely heavily on Excel spreadsheet, or sometimes even on decision on the shop floor. So there is a little support from your ERP system with the standard functionality. So it really relies on the planners to remember the sequence and remember all of those constraints, all of those ingredients, all of those constraints on the packing lines in terms of the setup times, and it's really up to the planners to try to do that manually in Excel. And what we try to do with Preactor is to move from that Excel and that decision on the shop floor and put it in the hands of planners. If you are a big company and if you are a large manufacturer, you probably would go into a situation when you just need to add more planners. Because that's the way most of the companies would work if they don't have the tool that can manage that centrally. So many of the companies that we meet, they have a problem with a central planning, so they have no central planning using global priorities, and they are looking for a solution that will help them to view the process from the start, so from your make operations until your pack operations, for example. Without the system also, there is no representation of actual capacity. So it's difficult to calculate how many shifts you require against your current plan. If you're trying to do it in Excel, there's little interactivity in terms of checking alternative resources, and because it relies heavily on the planners, you see no automation. You don't really automate those functions of sequencing. And most of the companies would need to optimize their schedule to reduce the cost. And one of the ways to do it is, for example, minimizing the changeover times. So when we talk about the food industry and those complex cleaning times that can go from one option to another, then this is the way to do it in terms of using a scheduling rule to get that optimization. We've mentioned the planning as a way to look on the longer term scheduling horizon or planning horizon, and in production schedule you would have a short planning horizon. So it's basically what you would do within that Excel is just to look for the next couple of shifts. So when you have a problem of the changes that are happening, so for example, you have new priorities or a machine breakdown, you don't really know how it will influence the production plan down the road because you don't see that in your current tool. Now, most of those examples that we are showing today is really for the combination of make to stock and make to order. But for those companies that are still doing most of their planning based on the make to order, in the make to order environment, the due date performance is also a big factor that needs to be taken into account. So you have a big pressure on the planning department in order to deliver the answer when we can deliver this this order, and without a proper tool to do that, they will struggle to do it in Excel or manual work. Okay, so that's how we talk about some of the problems, and you can see I've mentioned those problems that are typical for the food manufacturing, but also some of the common problems that are to do more with the process of planning. And now we're going to talk a little bit about how to solve those issues. So Preactor, it is SIMATIC IT Preactor. This is a product by Siemens. This is a range of planning and scheduling software. We have two systems which we'll be showing today. One is called Preactor Advanced Planning, and the other one is Preactor Advanced Scheduling. This is done because we understand the difference between planning and scheduling, and you might have different priorities in those areas. But of course, those solutions are also integrating. So, for example, your plan can be passed to your advanced scheduling module and back when you actually prepare a detailed production plan. Then it will be sent back to your advanced planning in order to say that, for example, next week it's already loaded in a certain times. Preactor Advanced Planning, this would consider your forecast and long-term orders to really set up and to calculate what is your production plan, what you need to produce, what would be your stock calculation, take into account all of those shelf life attributes of your products, and then also do a calculation on the materials. In the advanced planning, you will have the visibility across your planning resources, and as I've mentioned before, they can be multi-site, so they can be different factories. Now, in terms of advanced scheduling, this is the scheduling tool that is really to establish the production plan for the next day or week or a month. And this is where you go into that level of the detail when you see those different production lines, different packing lines. You manage your operators' availability, all those additional constraints. And also here you would use your advanced scheduling rules in order to plan, in order to schedule those resources, and for example to have that optimized schedule, let's say based on the minimizing of the changeover times. If you look from the data type, because one of the questions that usually comes up during this kind of meetings is also where our advanced planning and advanced scheduling fit into the world of the ERP system. So usually the advanced planning would be on the top. So you would take your forecast demand, you would have your stock orders, so you'd have your stock availability. You would set up some planning period using the planning attributes. You would set up your capacity, so how many hours of work, how many production hours are available in each week. And then you would generate the production plan to show you what quantities to make in which week. Once you have that information, you can pass this on to the ERP, and you can rely on the ERP system to generate the work orders. And then you would take those work orders together with the routing, the bill of material, all those detailed constraints that needs to be taken into account as well. You would take it into the Preactor Advanced Scheduling module, and there you would establish the sequence of operations and sequence of orders across your resources for the next couple, for your next couple of shifts or next couple of days, depending on the scheduling.
Question, but usually that data should be available in ERP.
Yes, exactly. So you could also take if you want to do that advanced planning calculations, you would take the data from the ERP as well. So forecast and stock orders. We are really looking at Preactor as something that will depend on the ERP data. Of course, you can put it directly in, but you would usually depend on the ERP data there. Okay.
Yep.
Some of the examples of the ERP integrations that are available really out of the box, Microsoft Dynamics IX and NAV. So in terms of, for example, scheduling, there are a couple of case studies, and we have this experience together with Columbus of integrating those both systems to Preactor, and we have some interfaces that are available to download the standard data from IX and NAV. Now, Preactor, in terms of the system, is a leader. There are about, I think we are approaching now 6,000 customers worldwide. There are different sectors. So food sector is one of them. There are implementations in the Baltic region with Columbus, so we can provide you with the case studies that we have together. There are different companies that are using Preactor. They can be mid-sized companies, but also the multinational companies that are looking for a longer plan time across very many different factories. The reason that we have those different sectors using Preactor is really about the flexibility of the system, how you can modify the system to fit the logic of the business rather than the other way around. We have a really large pool of functionality available, for example, to customize the scheduling rules that we want to use to optimize the schedule. So this is something that we also take into account, and this is something that is used by the customers. So let me move to live demo of Preactor, just to give you a little bit of a feel. I've decided to, of course, to use today an example from food manufacturing. So in this case, we're going to have two stages of production in that model. First will be make, so that will be the production of that specific product, which we selected today with cookies. So we're going to make some cookies, and then we're going to pack those cookies on the packaging lines. So we are looking at two levels in the bill of material. The first, you would have a finished good, and that would be your packed product, so your packed cookies, and then you have a semi-finished level, which are the cookies that will be produced. You will have different types of the packaging, so sometimes you might sell a pack of 5 cookies per pack, and sometimes you might sell the same cookie in the 20 per pack. So you will have different type of packaging, and that has to be reflected also on the packaging line, because those products also will have some additional attributes. So those additional attributes are flavors. So for example, you have vanilla, strawberry, toffee, and chocolate. There's additional attribute that we will use in order to generate the schedule, which is a gluten-free and non-gluten-free attribute. So those cookies will have different attributes there, and also the packages sizes that I've mentioned. All of those attributes will influence the setup time. So I've mentioned before that when you're looking at the scheduling, one of the important factors that you need to take into account is those setup time connections. So in that case, again, vanilla to chocolate setup time can be different if you change from chocolate to vanilla. So we will have some changeover times, and I will show you an example of those changeover times and how we can use them in order to minimize the changeover times. We will have a weekly demand for 3 weeks, and that's going to be about 50 work orders, and there will be separate work orders generated for a finished good level, so that will be connected to your weekly demand, but also we will have a semi-finished good level that will make the cookies, and then we're going to pack them on the packing lines. I will use two systems today. Those that are those two different solutions. One would be the advanced planning. So the first, we will really want to, based on the forecast data, we want to generate the NPS plan. So we want to know what to make and when to make this. And we will also have a look at the capacity utilization to have a look how this capacity will be used on our packaging and on our production lines as well. Then once we are done with AP, we will go into the production advanced scheduling. In order to schedule the production orders, we will analyze the connections between different stages of production, so between those making and pack operations. We will use our advanced scheduling rules to minimize the setup time. So we want to combine the product, so we want to combine the orders based on the flavor attributes, and I will show you also the sequence dependent changeover time. We will use a custom scheduling rule. The custom scheduling rule is really a scheduling logic that was built into the system to solve a particular problem. In that case, I would like to show you an example of a scheduling rule where we want to prevent cross-contamination based on the product key ingredient, so that non-gluten-free and gluten-free products cannot be made at the same time on production lines, and the scheduling rule must take this into account when we do the plan. And then finally, we will monitor the availability of operators. So we'll see how changes in the operators over time will impact our scheduling, and we will also calculate how many operators we would need over the current availability. So let me start with the system. I hope you can see it now.
Yes.
So this is our Preactor workspace, where you can see in some of those options that are used on a daily basis by the planner. There is a data maintenance tab over here, which will take us to the data in order to have a look at some key elements of what the information is taken in. So as I said before, what we really want to do today is to, based on the forecast data and also some stock for a finished good for finished good items and some sales orders, we want to calculate what we want to produce. So that would be our NPS value. In order for this to be able to calculate, we need to define a couple of key elements. One of this element is to define our planning resources. I've mentioned this before, that the level of the detail in the advanced planning is different comparing to what you would see in a standard scheduling module. So in this case, we are really looking at production lines, and we will have about 2 production lines in that example. How many production lines you have is really established through the calendar, so how many hours are available. And then you have another planning resource, which are your packing lines. In this example, we have 1 factory, but for example, if you had many factories, you would have factory 1, factory 2, or factory 3, and that would be your planning resources. You would group those planning resources into the planning groups. So in our case, it's really production lines and packing lines with 1 items each. But in reality, you could also have that capacity across many different resources. Once you define your resources and the level of the detail that you choose here, then you can define your items, or you can download it through your ERP. So in this case, you can see that we have that chocolate. Let's use that example of chocolate non-gluten-free cookie that goes into 20 pack, but it can also go into the 5 pack. One of the things that we define here is also rate per hour that will be used in order to calculate how much capacity we need for a specific demand that will be in the system. We are also defining a planning resource group, so we know which planning resource group to test. Again, if you would have some different connections, so for example, 1 product can be made in 1 factory, but it cannot be made on the 2nd factory, but you have another product that can be made in both, they would be a part of a different planning resource groups. There are additional planning parameters that are set here. They're called planning details. So for example, when we will be generating those production plan and production values, you could use a minimum reorder quantity or reorder multiply. So for example, you know that you cannot go over a certain limit, a certain minimum of the reorder quantity. And also there is a day's life for all of those shelf life parameters that you want to take into account. So for example, you don't want to plan something well in advance because it's connected with a shelf life of that product. We're going to treat them all of them as make to stock products in that examples, and it will also influence some other parameters in the system. One of the ways also that we use here is you can have a concept of target days of cover, so the system to calculate how much stock you need across days depending on the number of days that are your target. This is our finished good level, but also we need to take into account that we need to first produce that cookie. So in this case, we have our chocolate non-gluten-free cookies as a separate item. You can see that this will be done on production lines, and there will be a different rate per hour. Finally, because we have some materials, in that case, we have selected packaging. So each of those finished goods will also need some packaging, and this is not included in the planning, but it will be included in the material calculation. One step forward, and we are in the bills of material. So you have an ability to define the bill of material in order to reflect those different connections between your stages of the production. So that gluten-free cookie in the 20 pack, it will be made out of a gluten-free cookie itself, but also through the packaging that is required. You can see that for the material calculations, you can define also the lead time, because that could be used to generating the planned purchase orders. So once we define this, what we call static data, then you go into having a look at your transaction data. So first of all, you might have some stock take. So that would be your finished goods. So you know that you don't need to produce against your forecast if you have already on stock. So in that case, we have our stock count date and also the quantity. So how many packs of that chocolate gluten-free cookie we have available on stock. Then we have our sales orders. So that would be one sales order that we have put into the system with the order end and quantity that is needed. Again, this is something that will be used in order to calculate the demand correctly. Finally, we have an imported forecast. So that would be for each of the dates. So let me just have a look at one of our items. So that's our chocolate gluten-free cookie. You can see that we have an order end, so that would be the end of the week, so on the 10th, 17th, and 24th, and then we have a forecasted quantity. So that's something that's coming either from the ERP system or through the sales department, of course, as well, or can be imported through Excel, just to tell you what would be your forecast. Once we have this data, we can go and try to calculate the plan and to see what kind of visualization of our production plan is available. So what we're going to start with is that we're going to create a new plan based on our quantities. We have all the data for each of the week, but of course you can have it also on a daily basis or monthly basis. Here in that example, we're just going to use a weekly buckets of availability and the weekly buckets of your forecast against our current plan. One of the things before you generate the schedule is you set your planning horizon. So in that case, we have set up that we're going to look at 3 weeks, 3 weeks ahead. The first thing that's going to be calculated is that we'll calculate stock. So let's take our gluten-free cookie as an example. You can see that we had some opening stock of 200. I've showed you how this transactional data was imported. We have a forecast, which was 600, and then we have 100 in orders. So the demand that is required is calculated, but we are still going to calculate the NPS value, so that would be our production value. and then it's taken across all of those weeks. We can have a look from here just to give you an option on your stock profile. So that would be your stock profile for that specific cookie. You can see these are the negative values because we still haven't calculated the production values. Also on the top you can see what is your forecast or what is your sales order. So you can distinguish those two also looking at your stock profile to see which is coming from forecast, which is coming from your orders. But also we don't have the NPS values here calculated, so that's something that is needed to be done. So once we have that, we can go ahead and we can calculate the master production schedule. So that would be the values that are needed. So in that case of that specific product, we would have forecast 600, 100 in orders, so the NPS value of 500, because we already have an opening stock of 200, would be calculated, and then you would see those additional NPS values across all of your weeks. We can again go into our stock profile, and now you can see what would be your NPS value. So this is the production that is required in that week against that product, and also in the following weeks. Now, once you looking at that, what you need to do next is to have a look at your capacity. So what we're going to have a look here is the chart options, and we're going to look at our planning resource chart. So in that example, we have set up some number of hours that are available. So we had 120 hours available in each of the weeks. And then you can see how each of these NPS values against your products is using your capacity. So you can have a look here through all of those different products and how much demand is required and how it will use your capacity. Now you can see that we run it in the infinite capacity mode, so you can also see that it exceeds the capacity in the week 2. And this is to do with one of the specific items. You can see that in this case we have a promotion that is needed on week 2. This is our strawberry non-gluten-free cookie in 5-pack. You see we need 7,000. That would be the bigger influencer across all of our demand. So what we can do is, first of all, we can have a look at that row in the planning. So if I switch it off, you can see how many hours are used for that strawberry. So if I scroll here, I can see that we are using 46 hours out of our capacity for that specific product. What you can do now is, for example, you can use that. You can split the capacity by saying, for example, that we're going to move 2,000 of that into our week before. So what I'm trying to do is just manually try to level the capacity across all of those planning resources. And you can see now we've moved that capacity into a week before. If we now go into our planner, you can see there is additional information that will show me, for example, look out that we are making something too early based on the parameters that we have entered. Also, while doing that, level lower, so production lines and making of those cookies is also being calculated. So if we run it again, calculate the NPS values, it should also do bomb explosion based on the plan. So it will calculate how many of those cookies we need to make. And then again, we can have a look at our production lines just to see how we are using the capacity on our level 1 across all of those resources. Once this is done, and you can see and you can view all of those details together, the next thing that you can also do is to have to view your demand data and have a look at your MRP results. So it will also calculate for some of your, let's see, this one, it will calculate when you need the level 1, so that would be the lower level in the bill of material, but it will also calculate when do you need the packaging. It will give you a required date based on the lead time as well, so you can use that information. there as a sort of MRP result coming out of Preactor. There is a range of reports that will give you additional information. So for example, if you want to see some of the standard report lists, so you could see your demand items or plan comparisons. You can have different plans and you can compare them together. Once we have calculated all the NPS values and we know what to produce, and let's say we use those manual or more automatic things to smooth out the plan, then we are really able to export the planning results, and they can be used by the ERP system or they can be used by your scheduling module. So now that we have the NPS plan, let's have a look at our scheduling module. So we switch to the different system, and now you should see our production, the planning board. So instead of looking at all of your production lines or all of your packing lines, you're really looking at very specific lines that you want to schedule for. This is the planning board. So on the left, you will see all of the resources, those two different departments, production lines and the packing lines. And then all of those work orders are already generated. So on the bottom of the screen, we have our chocolate gluten-free cookie. We already have how much quantity has been ordered. And also there will be a semi-finished level. So one of the things that you want to see is that you want to schedule them accordingly. So I'm going to highlight a specific order, and then I will schedule them onto the planning board. And let me just bring it up a little bit just to show you the connections. We have some standard calendar that you can set up. You can have production lines with different calendars and packing lines with different calendars. In this case, they all have the same number of hours, which basically means 2 shifts per day, and then switch off for the third shift. Here you have an example of the connections between those different products. So in that case, we are producing. This is the making part where you have a production line. You can see that the time that is required for the production of that quantity has been calculated. So that's about 18 hours that are required. We're going to start at 6 o'clock on the 6th of June, and we're going to finish on the next day. When we're going to produce that on the production line, then we can satisfy our packing. And in this case, as I've mentioned, we are packing this into packs of 20 and packs of 5. So you have 2 different work orders that are connected to one production line, and you can see that connection that goes over here. So whenever you're going to do the schedule in Preactor automatically, all of those relations between the production and the packing will be taken into account. There is additional way to view that. So you can go into select one of your packing, and you can display this in the material control. So in that material explorer window, you can see those connections, and you can see also the connection to your demand. So this is my demand on that week 1. When I need 500, I'm going to produce 500 on that packing order, and then we will require some packaging. And we have this packaging available on stock. So you can see a link between the stock and the packaging that is required for that production order. And then there is a connection between the packing and the production line as well. I can go into that production order of that cookie, and then I can see that it will be consumed by 2 different work orders. That's an example when you have one big order, the production order that will supply your packing across your packing lines. You might also have a different situation, and let me see here. Let's highlight previous operations and let's schedule them. This is a different case. This is a case when we are doing the vanilla and chocolate, and then we are mixing them together in the packing. So we are producing 2 different work orders on production line and production 3. And then they will go into the mix in order for you to see that those 2 chocolate cookies are needed in that pack. So you have to mix them together. So one cannot go without the other one. So that's why you have that connection between those 2. And if you go into the Material Explorer, you will be able to see all of those orders together again. This is your packing, and this is your production. So that's how we can deal with connections between different departments. What you really want to do now is that you want to schedule everything. So what we're going to do is that I will unallocate all of the operations and I will schedule them automatically. We're first going to just schedule them using a simple rule, which is scheduling forward by due date. We know when those packing orders are needed and when we need to make those production orders. So we're just going to schedule them like this, and I will zoom out just to show you the plan overall. And what you can see here is that we scheduled all of the orders. We might look at a window where it will show me some problems. So whenever I have some order that might be possibly late against the due date that is required, it will be shown in that window, and then you can make some adjustments to the plan, such as adding another shift in order to be on time for that order. One of the things that should be quite visible here as well is also to do with the setup times. If I scroll and zoom in a little bit in, let me show you this in this way. You can see that there is a black bar that is before the order. So whenever we change from one product to another product, there is a setup time. And if I try to put something like this, you can see the difference in the setup time. This is because we are using those sequence-dependent setup time matrices. In this case, when I'm doing production line from vanilla to chocolate, I need a setup time of about 3 hours in total. I'm changing the two attributes. I'm changing the flavor, but I'm also changing that non-gluten attribute. So they might be combined together. So I changed from one product to another. The setup time is calculated automatically. If I try to make a setup time like this, you can see that it's going to be longer than the one coming from vanilla to chocolate, because that's something that is connected with the sequence-dependent setup times. Let me just show you. If we go out of that schedule, we go into our resources, and I will have a look at production line. And there is our sequence-dependent setup time. So you can see exactly that if I change from chocolate to vanilla, I need 3 hours of a setup time. If I change from vanilla to chocolate, I need 1 hour and 30 minutes. This is the way we change the setup times for flavors, but we also have that big cleanup that is needed, because whenever on those production lines you go from gluten-free to non-gluten-free, then you need a big cleanup of about 3 hours or 4 hours if you go from gluten-free to non-gluten-free. If you go from non-gluten-free to gluten-free, you need a little bit more time. So let's go back to our schedule and let's see how we can use this information in order to generate a better schedule. So first, what we're going to do is that we're going to go for our data. There's a KPI window here above our schedule that will give me the scheduling rule name that we will use, the number of late orders, the setup time that we need, and also the number of setup times. So if I generate my schedule according to our standard rule, which would be just schedule forward using a due date priority, you can see that I have 1 hour, I have one order that is late, and then I have about 97 hours of setup time. So that's the total of all of those black bars that are on the plan. So what I want to do now is I want to generate a schedule that might be a little bit different. And for this case, we're just going to use a rule that will minimize the setup time within weeks. So in these circumstances, when you are forecast-driven and in a forecast-driven environment, and you have all of this demand that is needed at a specific week, what you would want to do is that you don't want to push your production from week 3 into week 1 just because you want to minimize the setup time. Ideally, you want to minimize the setup time within those specific weeks, and this is what the rule should do. So you can see that we have the same result in terms of number of late orders, but you can see that we have a much better total setup time hours in that case, because we were able to decrease by almost 50% the setup time just simply by scheduling this according to our weekly orders, where we want to minimize within those weekly orders. You can see that we have 48 hours, and now we have about 33 hours, 33 setup times in that schedule. So that's what you would normally use. You would use a combination of looking at your due date performance, because you still want to do it on time. So that's why we use that week parameter as one of the ways to do it. But also, on the other side, you want to optimize because you want to reduce cost. And the way to reduce that cost is also to do that with minimizing of the setup times. So once we are done this, we will have a look also at some custom scheduling rules. So I've mentioned in the custom scheduling rule, I've mentioned that what we will want to do is that we will have a look at some additional attributes. So we have something which we call cross-contamination rules. So in this case, you can see that we have defined that if this attribute, which means gluten-free, cannot be produced with non-gluten-free while we are having production line, while we are doing this on production lines. And the same, the other way around, non-gluten-free cannot be produced at the same time as gluten-free. So we're going to go back into our schedule. And what we're going to do is that we're going to use that scheduling rule to give you an idea what happens. We're going to use prevent cross-combination within weeks. So what we are basically doing now is we're checking different parameters against different production lines. We're trying to do it within weeks. So we're going to have those different schedules, trying to minimize the setup times as well. But what happens here, you can see this exactly in the week 1. Once this is scheduled, you can see that we have this gluten-free attribute that is also visible in the light green bar on the planning board. And you can see that we cannot start non-gluten-free until we finish all of the gluten-free cookies. So basically, this space on production line is not used because we are waiting until we can do the big cleanup, and this is our setup time for the cleanup, and then we can start to produce the non-gluten-free. If I try to do something like that manually, the planner alert would pop up to show you that you are trying to schedule the gluten-free cookie here and non-gluten-free at the same time. So that's an example of a scheduling rule that uses the custom attribute. And now let me just show you what we can do with the operators. So in that case, you can also calculate how many operators you need. This is an example of a plot where you can see how many operators on make area and how many operators in the pack area you have. So in this case, you have 20 operators that are available on in the make area, and you have 27 operators available in the pack. You can see how many of them are being used. What you could do is automatically disable scheduling rule, secondary constraint, and also calculate how many you would need. That's also one of the things that is possible to be done in the system, where you can exceed the number of those operators available. Now, if you have a situation when you would decrease the amount of operators that are available, so we have a max window of 20, and then you would try to schedule this again. You could see how many of operators there will be need over the maximum value that you would need to define. So that would be the way to analyze how many operators you would need. So that's another way of looking at your schedule and at your schedule as well here. Okay, so that's a very brief outlook on the advanced planning and advanced scheduling. So some of the scenarios that we tried to show you here today was to prepare an NPS plan using the forecast data. This is something that we did in the AP model, And then we moved into the scheduling to see the connections between different stages of production. We used the scheduling rule to minimize the setup time by combining orders together. And then an example of a custom scheduling rule to prevent the cross-contamination based on those ingredients. And then finally we monitored some operators availability. So, presentation. I think we lost. Let me go back into that presentation, and I will finish it off with a couple of points here. In regards to the potential benefits and what you can expect, one big part of that conversation is not only the system and how it can handle those different elements and those different elements of functionality that you have available, but also there is a question of how you want to run your process together with the system. And most of the companies that would like to have the improvements from using advanced planning and advanced scheduling modules, what they are really looking at is trying to take it away from the planners in terms of having to do all of that manual work inside the Excel and trying to move to a more automated way. So one way of doing that is to use the power of the scheduling rule, and the other one is to look at the way to centralize the schedule. So in that example that we use for the food manufacturing, we use that make and pack environment when you can see those connections together between those different orders. We have a case of a company that was using this in a manual. They were trying to do the production plan in a manual way, and they have reported in case study, and the case study is an official document that is signed off by the companies that are using Preactor, and they have reported about 70% of reduction in time that is required for production planning. Now, in regards to the customer service, we are talking more about the make-to-stock approach, but of course, at the end, there is also a customer that needs information when we can deliver. So our ability to quickly give that information through the production plan, additional view, all like in the case that you've seen in the system, where you had an example where one of the orders was potentially late. You can use that information to communicate that, or you can react by changing the plan. All of that should lead really to lowering the cost of delays and having a better scheduling horizon. So looking at more days ahead than you would normally do with a manual way. We had some of the users with case studies that have reported about 80% of improvement in delivery performance by using a scheduling tool and having a better view of their resources. In terms of the productivity, the big part really of the cost saving and possibilities within the food manufacturing is probably that dynamic aggregation of operations based on the attributes. So all of those things that when you need to minimize the setup times and you need to minimize the setup times and the cleaning times based on those matrices, this is the power of the scheduling rule, and that should bring also those additional benefits. We have examples of customers in different industries that are better using the subcontractors based on their real production plan in order to make sure that they can sequence the subcontracting work against the work in their environment. Another expected improvements, it's in regards to the material management and reduction of the time that is needed to actually produce. We have examples of customers that were better able to synchronize the operations between departments, so just like I showed you with the make and pack departments, and also to better synchronize the production plan against your raw material purchases. So once you have a production plan in a longer horizon, you can use Preactor to calculate materials that are required, and also, if it's possible, you can synchronize those purchases against your production plan, because with Preactor you know better when you will be able to make some of your products, and then you can synchronize maybe not all of your ingredients, but for example maybe some of your packaging materials as well. So we have examples of users that have reported a reduction in raw material stock as well. I encourage you to have a look at our case studies. You can reach out to us in terms of the case studies that are available for your specific industry. There are quite a number of different case studies from different companies in the food manufacturing that are available on Preactor.com. The numbers that you see here, and I've related those numbers to that specific cases in terms of where you can expect those benefits. This is something that has been calculated by the users together with the implementers around the world, and it's included in the case studies that you can see on Preactor.com. So I think we're going to spend about 5 minutes just seeing if you have any kind of questions and answers, and I'll be able to hopefully we'll be able to answer them. You will be able to, if you could put that in the moderated chat, then I will be happy to answer those questions. And just to give you an idea before we go into finally the thank you, if you would like to learn a little bit more about Preactor, then you will be able to contact one of your local Columbus offices. They are available for you, and you will receive that contact details in the email after that webinar. If you have some specific questions, we are also available here. So before we moderate and we go ahead, let me just make. I will stop sharing the screen. We'll be available to make to answer some questions. And let me make Dovidas moderator again, as he was disconnected.
Right, again. Sorry, I was kind of lost my moderation mode. Michal, a couple of questions while I will read the question from the guys. So first question. So you do believe that, I mean, we understand that companies have their own ERP. So how Preactor interacts with ERP production planning function, or as such, the production plan, which is generated by kind of NAV, Exapto, or other ERP software?
Mm-hmm. Yes. So basically, what you have in Preactor, because we can divide this again into the planning and scheduling. In terms of the approach that you take, you of course some of the functions in the generating the MRP functions, this would be normally in your ERP system. So for example, in AX you would have the master plan where you can generate what you make, and that would be perfectly well function that you want to stay and use. You can use that advanced planning on top of that if you want to have that additional visualization and additional calculations. In order to take into account your finite capacity. So all of those capacity calculations that we made were really there to supplement the functions where you want to calculate the master plan. I've mentioned the data that we take in from one system to another. So from the ERP, we would normally take your forecast data, you would take your stock, you'll take your stock forecast sales into the AP product. Now, in terms of the scheduling, it's more in terms of taking the data that is concerning the routing, the work orders that have been generated by the system. And also take into account, for example, those additional elements, such as what tools you need against your operations. Also, in the scheduling, you can have a material control functions as well. So that would be more or less the scope of the data that is needed to take in. But of course, you can decide which module you want to start with. And just last point on that, Probably most of the companies would really start at the scheduling level if they have the ERP system before moving to the AP.
Okay, so before I give my own question, there is I have also posted one question from the audience. So it is on your screen, right?
Yes. Okay. So
it is related to the scrap.
Yes, yes. So you can take into that account either in the AP and yes, so there are some additional parameters that you can set. So that calculation of the NPS can take that into account. Now, in most of the cases, in terms of reporting the actual production, we would rely either on the ERP system or some additional applications such as MES systems in order to actually report the production. That production would actually be available to Preactor, so you can update your schedule with the actual produced quantity. You can put it directly into the Preactor, but you should be more comfortable with actually doing that in the ERP system. Just to go back on the IX point as well as an example, whenever you produce something in IX, when you report quantities in IX, they are then taken into account in Preactor when you generate the schedule. And the last question concerning the planning and scheduling worksheets. Well, all of those plans and those schedules that you generate, you can save them. And then you can trace back that as a history. So you can save a copy of your plan. We have users that are really saving this at the end of the day, and then you have an archive of all of the plans and all of the schedules that have been generated.
Okay, so we have still 4 minutes to go. So one additional question from my side. So we do believe that this is like the system for planning and for production, but in general, how it helps for the salespeople and the people from purchasing department?
Mm-hmm. So the first point that you really start with is that you try to what you try to do is that you look at the process, and you try to define during the implementation in the very early stages. You try to define the planning procedure, and that planning procedure would also involve all of the information that you have to distribute to the sales department, to the purchase department. Let's look at the scheduling. From the scheduling point of view, you have the due date performance reports that are available for the sales department that will show you in the current schedule, can you deliver late or not on that specific orders. And this can be used in order to analyze the delivery performance and to connect back to the customer. From the sales part, the sales department, you might also have order inquiries that can be done in the scheduling module. When you want to put some quantities and you want to check when can we deliver this order inquiry. So you put an order inquiry, you get the date back from the schedule to give you information when we can deliver this order based on our current schedule. For the purchasing department, we supplement them with the information concerning the material shortages. So for example, whenever you don't have something on stock or you don't have that on purchase order, you'll have information about, look out, this is your material shortage and you have to deal with it if we want to start producing at a specific date. So that's something that we will take into account as well.
Okay, so maybe one of the last questions. Could you elaborate a bit more on the scheduling rules? What are the list of those rules in Preactor?
Mm-hmm. So you have a standard of scheduling rules that would be, for example, to do with the way you do you can do forward scheduling. So that would be to use the resources as quickly as possible. You can also do the backward scheduling. So you want to make it as late as possible, but still according to your due date. You might use different priorities. These priorities can be assigned to the customers or to your products. And also the due date priority is one of those that are more frequently used. Now this is your standard rules, but then you go into more advanced rules that are also available, and we have an industry standard tens of scheduling rules that you can use. Today we've showed one example, which is an example of minimizing the setup time. It's one of those advanced scheduling rules. So you really want to take that power of those scheduling rules, when you have those changeover matrices and you want to combine like-to-like products together. There is a preferred sequence rules where you can actually define what should be the sequence on the resources, and the schedule will try to fit that into the production plan. If it's not enough, then you also have your custom scheduling rules that can be built into the system, and this is something as implementation team will do for our customers on a regular basis. So if you have some specific logic that preventing cross-contamination based on key ingredients, this is something that we did for a customer, and this is an example of a custom scheduling rule.
Okay, and thank you for that answer. And I would say the last question on this webinar, and that is related to the price range for this solution and rent. So, of course, I can answer it, but I would like to hear the answer from you. How do you see the range which is in the market? Let's call. How often and what are the real ranges?
The price ranges. Okay, so yes. what you're looking for, first of all, in Preactor we have different let's say versions of the product. So you can start with a standard version, then you have a professional version, you have an ultimate version. If you are looking at something of a let's say an ultimate, which would be top range of the product, you're really looking at something of a budget of up to 40,000 euros if you're looking at that option.
But from standard version, so actually this is the license plus deployment.
Yes, that's true. The standards would be, of course, a little bit lower. I've put you as a top number really to look into in terms of the licenses if you want to combine AP and AS together.
Right. So having said that, Michal, I would say we're running out of the time, so we should stick to the plan.
That's correct.
I'm very thankful for participation. Thank you for the questions we got, and thank you, Michal, for the very nice presentation. So anything from your side as a highlight?
Thank you very much. Thank you very much for your time today. We will have the materials available to you, as David has mentioned before. We are very happy to talk to you on specific problems that you have in your companies, and to look at the way we can present the system to you using your data, for example. And we are quite open to do that. So please keep in touch.
Right. Thank you, and bye-bye, everyone.
Okay, thank you very much.